There's a fruit fly walking around right now that was never born. It is entirely simulated. Scientists took a real fly's brain, mapped every single neuron, dropped it in a body, and it just started walking around and behaving like a fly. No training data, no AI, just biology copied. And the company behind it says humans are next. So this is Michael Ondrag, and he's part of the team that did it. So we've uploaded a fruit fly. We took the connectome of the fruit fly brain, applied a simple neuron model, and used it to control a physics simulated body, closing the loop from neural activation to action. This fly, as he says, has a 91% behavior accuracy with only 4 things. 1, the graph of the connections. 2, the weights as determined by the number of synapses connecting those neurons. 3, a map of excitatory and inhibitory neurons, and leaky, integrate, and fire. And if these sound confusing, let me break it down. So the graph of connections basically just means taking all the neurons and figuring out how they connect to each other. The weights is very similar to how a traditional large language model works. It is a way to basically predict behavior. The map of excitatory and inhibitory neurons basically means the neurons that say, yes, go do that, or no, don't do that. Like fire is hot, don't touch it. And food good, go get it. And the leaky, integrate, and fire is just a rule set that determines how neurons will actually fire. Now here's where it gets wild. He says, now let's think about the fly. This is, in our view, a real uploaded animal. Their team truly believes that this animal that they have basically cloned and digitized is completely real, and they want to treat it as such. We don't know what its experience is, nobody does, but we take the possibility seriously, and we're working to give it a rich environment, not just a test box. Because who wants to be dropped in some weird simulated environment? You want to feel right at home, and they're building that for this fly. But why are they doing this? Is it just because it's really cool? Well, no, there are actually huge benefits if we can get this right. So the fly is just the beginning. Here's the bigger picture. Emulation helps with 3 things: understanding the brain and treating diseases. So if we can fully simulate a human brain, we can also simulate when things go wrong with it and potential solutions. It also helps with discovering intelligence algorithms that evolution invented in the most expensive training run in history, being evolution. Basically, we have been evolving for millions of years. And if we can use some of that learning in how we're developing our own artificial intelligence, then we might actually be able to unlock things that large language models alone can't do. And then 3, uploading. Yep. He literally means uploading your consciousness. But there's so much to unpack here. If this team is able to eventually, maybe way in the future, maybe not so far in the future, but upload a human brain and fully simulate a human brain, maybe that is truly our consciousness uploaded. And what if we just turn up the GPUs? Maybe we can start thinking 1,000 times faster, 1,000,000 times faster, but we're still ourselves. It's so fascinating to think about. And there's also a lot of parallels to be drawn with artificial intelligence, because AI very soon, if not already, is going to be smarter than us. But not only smarter, it's going to be able to operate orders of magnitude more quickly, and it's going to have parallel scaling as well. So now imagine your brain could do the same thing. Your brain superpowered, and then 1,000,000 of your brains all working in collaboration with each other while you are still a human in the loop. And by the way, I know this all sounds like science fiction, but you know what isn't? The sponsor of today's video. Zapier released an MCP server for thousands of MCP tools. They've been a fantastic partner. I've literally used them for 10 plus years in my own businesses. So if you're doing anything with OpenClaw, you should also be plugging in Zapier. So check this out. All you have to do is connect your agent, your OpenClaw, to any app within Zapier's MCP service. It's like giving your agent thousands of tools instantly. And Zapier has been doing automation for a long time, so they know exactly how to make it work reliably. They have over 8,000 different apps available to give to your agents right now. And you can set it up all without writing a single line of code. They have a free plan to get started, scale up as you need from there. So check out Zapier, set up your MCP, connect it to OpenClaw or Claude Code or whatever you're using, and try it out and let me know what you think. I'll drop all of the links down below. Thanks again to Zapier, back to the video. And so what did this team really do? Because connectomes and simulating neurons of animals that are this small and have this few neurons has been done in the past. Well, what makes it really special is they took the brain, they also simulated the body, which hadn't really been done before, and then they put it in a simulated 3D environment. And just with that, we saw life. We saw this fly with no other training do fly things. So the result, multiple distinct behaviors driven by the emulated brain's own circuit dynamics. This is, again, what he was just talking about. Evolution got the fly to where it is today. We basically just mapped the neurons. Think of it like this. Imagine we just found ChatGPT out in nature somewhere, and we took it, we digitized it, and then we started using it. And it didn't actually require any training. You know, the billions and billions of dollars that frontier companies like OpenAI and Anthropic spend to make a model from nothing into the incredible intelligence we see today. Imagine you didn't have to do that. Imagine we just leveraged evolution, which has basically trained every model on Earth, every human brain, every animal brain. It's kind of wild to think about. We don't actually need to do the training run. Nature already did it for us. So sensory input flows in, neural activity propagates through the complete connectome, motor commands flow out, and a physically simulated body executes the output, closing the loop from perception to action for the first time in a whole brain emulation. And here they even mentioned the C. elegans project, which I covered about a year ago. So this OpenWorm project have attempted embodiment, but with far smaller nervous systems, 302 neurons, and limited behavioral repertoires. So now we just have a fly that can do so much more, is so much more sophisticated than that worm, and it's only been a year. Now, listen to this. Watch the video closely. What you are seeing is not an animation. It is not a reinforcement learning policy mimicking biology. It is a copy of a biological brain wired neuron to neuron from electron microscopy data running in simulation, making a body move. The ghost is no longer in the machine is becoming the ghost. And so it's obvious that we are progressing very quickly from just 302 neurons a year ago to now 125,000. But where do we go from here? Let me show you some animals and how many neurons they have and what it would take to fully upload their brain. So here's C. elegans right here at 302. A starfish has 500. Let's go all the way up to the fruit fly, which it says here is 150,000. We have ants at 250,000. The honeybee at nearly 1 million. A turtle at 8 million. Bats have 35 million. An octopus coming in heavy at 500 million. By the way, one of the smartest animals on the planet. And yes, you can draw a correlation between the number of neurons and how smart they are. Then we have the Western gorilla at 9 billion neurons. And all the way at the top of the neuron food chain, we have orcas and humans. Now it says humans only have 21 billion here, but everywhere else I'm reading, we have 86 billion. Now on the flywire.ai website, you can see that they have mapped the neurons of a bunch of different parts of the female fruit fly. And by the way, if you want to actually see the neurons, play around with it in 3D, you can do so on this website. Looks like it's brought to you by Princeton University, but you can see right here is one of the examples, and you can actually go in and see every single one of those connections between neurons. It is absolutely fascinating to think about. So what does this actually mean? Have you heard of simulation theory? You can kind of think about it like what happens in the Matrix. It's basically a theory that says everything that we're experiencing is a simulation, meaning we're all in a big video game. And if that's true, who made the video game? Who's running it? Who's playing it? And as more and more investment gets poured into artificial intelligence, massive data centers are being built out that can simulate artificial intelligence. Why couldn't it also simulate human intelligence? And I just want to share one more thing while we're talking about complete science fiction. In this absolutely viral video, a petri dish full of human cells have learned to play Doom. It's wild. Watch this. absolutely insane. So what we have here, we basically have a computer right here playing Doom, but being controlled by human brain cells in a petri dish. The human brain cells send out the signal and control the video game. So now you know it really only takes a few brain cells to actually play Doom. And so what you're seeing here is the actual brain cells firing and controlling, and then this is what the human brain cells in the little petri dish look like. But this is just more of the same. The rate at which we are learning to manipulate science is stunning. So maybe we'll be able to grow human brain cells, get them to compute things for us. We're going to have fully simulated brains on the internet. I mean, what a wild future that we are accelerating towards. So let me ask you something. If one day this company is able to fully simulate a human brain down to the neuron, every single connection that we have, and then upload that into a computer and it starts behaving exactly like a human, is that a human? Is that me? Does that mean my consciousness has been uploaded? And if that's true, do we all live forever suddenly? Can we be given superpowers simply by tuning some dials in that simulation? It's so wild to think about all of these possibilities, and we are accelerating towards that outcome. It seems inevitable that we are going to be able to fully simulate 86 billion neurons, especially at the rate that software is improving, hardware is improving, massive investment is going into all areas of artificial intelligence, which is basically the same tech that can simulate human consciousness. So let me know what you think down below. Is this fly real? Is that fly actually living in the simulated environment? Let me know. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.